In our last video, we saw we could use prefixes when measuring really large or small values. However, there's another method where we can do a similar thing, and this is called scientific notation. And scientific notation is pretty common. It can be used in place of these prefixes in many cases. So scientific notation can also be used to express really large or really small numbers. And let's take a look at how this is generally formatted. So the way we do this is we start out with some number, and this number is then multiplied by 10 raised to some power, and I'll call that n. So this is the general format for writing a number in scientific notation. And I wanted to point out a few different things, and that is that the number that you list first should be a number between 1 and 10. And it can have a decimal. So for example, we could have 1.5. However, we wouldn't put 0.5 because 0.5 is actually less than 1. So we wouldn't want to put that there. Instead, we'd change it around a bit. We also wouldn't want to have something like 12 in this spot because that would be larger than 10. So we do want to have a number that falls between the range of 1 and 10, and it can have a decimal. In addition, over here, we've got this n value, and sometimes students look at me and they're like, well, what does the n mean? And in this case, n is a whole number. And it can be positive or negative. So it could be 1, 2, 3, 4, or it could be even -1, -2, -3, or -4. But it has to be a whole number, meaning no decimals are allowed in that n spot. The reason we use scientific notation is it gives us orders of magnitude. So was it 10 times greater, 100 times greater, 1,000 times greater? And we need to do that by using n values that are whole numbers. We don't want to use fractions or decimals there. So let's take a look at this in practice using a few different examples. And it's actually not as scary as a lot of people see. So let's write down just a number right now. So I'll do 1, 2, 3, 0, 0, 0, 0, 0. And what we want to do is convert this to scientific notation. So in this case, what I like to do is draw an imaginary decimal point where it would be. So in this case, because it's a whole number and it's greater than 0, this would be my imaginary decimal point right here, this little green dot. And what I would do is I'd say, all right, we need to move this just to the right of the first non-zero digit. So I would go move it right in front of that 1. And then I would count the number of spots that I moved it. So I went 1, 2, 3, 4, 5, 6, 7. So now when I go ahead and rewrite this, I'd say 1.23. We can even ignore the rest of the zeros. We're going to assume this wasn't measured or anything. And then I'd say, let's raise this to the 10th power, or sorry, 10 raised to some power. And like I said, we went 1, 2, 3, 4, 5, 6, 7. So this must be to the 7th power. So this indicates the number of decimal places we moved to the left. So this 7 can help you out with that. And like I said, this number right here is between 1 and 10. So this works out, right? We wouldn't, for example, want to move this decimal point after the 2 because then it would be 12.3, which is greater than 10. So always try to shoot for the first non-zero digit. Let's do another one. So this one I've got 0.0000145.3. So in this case, it's a pretty small number, not a really large number. But same idea, right? I'm going to move this decimal, but in the opposite direction. Like I said, we always want the decimal to be just right of the first non-zero number. So in this case, I would go ahead and I would move it right after the 1 here. So in this case, it looks like that decimal would then change to 1.453 because now the decimal is after the 1. And then we would multiply this by 10 raised to some power. In this case, we could count the number of spots. We move the decimal. So I'd say 1, 2, 3, 4, 5. So we moved it 5 spots to the right, which means we need to do 10 to a negative power because this is smaller, right? So I would go ahead and say 10 to the negative 5th power, right? So let's make some notes here. So it's positive for large numbers. And over here, this is going to be negative for small numbers. So that's one easy way to remember the sign is if we look at this number, I'd say, well, hey, that's really small. That's a lot less than 1. So we're going to have a negative exponent over here. Where if we were looking at this example up here, that's a really large number, right? So we would say, well, that should have a pretty, it should have a positive exponent for the 10th place. All right, so let's take a look at some multiplication rules here. And this is handy, especially if you don't have a calculator. In fact, I encourage students to try to do as much math as possible without their calculator, because I've noticed when students over-rely on their calculator, they tend to make kind of silly calculator mistakes. So let's say we've got this scientific notation value. So it's a raised to, or a multiplied by 10 to the y. And I want to multiply this by a second one, which is b times 10 to the z. What we can do is we can simplify this mathematically, and we can multiply a times b, and then we can just raise this to 10 to the y plus z. So what I mean by that is this y value here and this z value over here just get added together, which is kind of handy. So let's take an example. So let's say I've got 3.0 times 10 to the 8th, and I'm going to multiply this by 4.0 times 10 to the negative 2. All right, like I said, there's a lot of ways you can mess this up in your calculator, but let's try to do this using our math tricks, right? So if we look at our a and b value, over here, the a value would be 3, the b value would be 4, right? So I would go ahead and I would just say, well, this must be 3.0 times 4.0. So 3 times 4 is just 12, but we'll do that next. And then over here, we'd say, all right, let's do our 10. And then we'd say, well, we need to add 8 and negative 2 together. So let's go ahead and do that. But we have to be careful, right? So if we do 8 plus negative 2, that's really just 8 minus 2, right? So let's simplify this down further. So now we've got 12 times 10 to the 6th, right? But this isn't quite proper scientific notation, because when I look at this number, it's greater than 10. So what do? Well, we could say, we could imagine this imaginary decimal. Let's slide this over one more. And because this is a number greater than 1, it should make this exponent over here jump up to a higher number, not go down. All right, so if we change this to the correct value, this would then go to let me change colors here, 1.2 times 10 to the 7th, because we moved that decimal spot one place over. So like I said, I prefer doing it this way. It avoids any of the mistakes on your calculator where you forget a parentheses or make some goofy typing error. Just try to do it in your head if you can. It's a lot easier to validate your work. All right, let's look at division. So up here we did multiplication tricks. Let's do division tricks. And it's pretty similar. So if we have some number written in scientific notation. So that's a times 10 to the y. That will be on top. And I'll just put this in parentheses to be thorough. And then down here, I'll do my second value, b times 10 to the z power. We can simplify this mathematically, and we can say, well, this is just a divided by b times 10 to the y minus z, not added together anymore because we're doing division. So let's take a look at an example. Just like we did up here, we'll do the same values. So we'll do 3.0 times 10 to the 8th and 4.0 times 10 to the negative 2. So let's do 3.0 times 10 to the 8th, and we'll divide this by 4.0 times 10 to the negative 2, and let's simplify this. Well, we know it would be 3.0 divided by 4.0 in our first spot, right? And then over here, we'd say this is 10 to the 8 minus negative 2. But because we've got these two minus signs here, right, those will actually turn into a positive sign, right? So in this case, it would be the equivalent of saying 8 plus 2. So let's simplify this even further. So we've got 12.0 times 10 to the 10. Okay? Or actually, shoot, I'm doing multiplication, not division. This would be 0.75, right? So it's 3 divided by 4 would be 0.75. But like I said, we want this number to be between 1 and 10. But right now it's below 1. So let's figure out how to fix that. So what we need to do is move this decimal point over here. So if you can see, we're dealing with a number less than 1, which means that this number, instead of rising, is actually going to drop because we're dealing with a small number. So let's go ahead and fix that. This would be now 7.5. And because we move that decimal one spot to the right, the exponent will drop one value, and this will be 10 to the 9th. So I hope this is helpful. I know a lot of you may have seen this in your math classes, but we'll be using both the prefixes to express large and small numbers, as well as scientific notation. So I want students to be able to understand how to use both within this chemistry course. All right, good luck, and email me if you have any questions.